take that long question, okay, for tomorrow discuss. Tomorrow also. Okay, I'm presenting a lecture notes on today's topic, which is actually an algorithm. Uh, uh, Basic NLP task also. For example, the first task in NLP is looking for to solve like spelling error or what we call as string manipulation of string. Okay. So one technique that we can use, first from last week we have done text pre-processing. So after we identify our text, so we can do a few operation. And in terms of application with string also, we can always do a lot of application, for example, like spelling checker to check like for example, when we use search engine, when we type it wrong certain words, so we wanted to do like auto replacement and this kind of strings application. Okay, we wanted to do an application that is based on strings or simple operation on the text that involve, for example, like spelling error, and also even to replace a word with another word. The concept is usually okay. When we use text, okay, when we use text, you will just have a look again with the structure of a text. Then when we look at text, for example, this is a title, okay? Natural language processing is a special name, okay? However, when we look at the structure, natural language processing is made up of three lexical or three lemma, for example, like this is three entry of words, and in which we will be able when we use we do text pre-processing. You know that we can do token. We will able to tokenize the word into three different words or three different input here. And then if we look at each word, at each lexical, you will also be able to see there is a structure also. This the word or the term natural is made up of 1, 2, 3, 4, 5, 6, 7 character. Okay, so this 7 character also can be tokenized. Okay, you can also tokenize it per character or as a string, per string. Okay, what I wanted to explain here is when we look at a text, so a text is made up of a character that form a word or a lexical, and then a combination of a word will form a phrase, and then it become a clause. Next, it will become a sentence, and then a sentence. When you combine sentence, maybe we will. Okay, when we combine, but this is in point form. If I wanted to describe, okay, when we look at a sentence, for example, it's actually a clause. Okay, a searching keyword is actually a phrase, and then via the net is another clause. When you combine them together, it becomes a sentence, and then a sentence. When we combine a sentence, it becomes a paragraph. For example, okay, Malaysia is a federal. I need to show you a long essays. Okay, so however, I hope you get the idea that when we process text, then you will look into the structure. where actually either it is a word, a sentence, a paragraph, or the whole discourse is actually made up of similar structure. Where we can token, for example, if you are given an essay or a report, the first part that we can do is to segment the paragraph. Okay, after we segment the paragraph, then we segment the sentence. Okay, then the sentence you can always token or segment the word. Okay, so the larger it is, so we can always do the segmentation. So the same thing for a phrase, I will be able to cut it into 3 different words. However, if I look into one word only, I can also do the token based on the string or based on the character. Okay, so what operation can we do in order for us to process and also to generate natural language? So the first thing that we will look here after we do tokenizing and so on. So this is some application that we can always process. Okay, we can check, for example, how similar are two strings. Okay, this is very important for spelling checker, or if you wanted to build a word processor, for example, if you wanted to build a Microsoft Word, for example. So you will have a word processor that we can process, checking the similarity of strings and so on. Okay, so for example, in spelling correction, the user type market. Okay, we always, we always wrongly type something because we wanted to do our thing very fast. So how are we going to predict? You can build a predict system, okay, to predict what will be the, okay, from this, what will be the nearest? Is it market? Is it mark? Okay, is it make? And so on. So how are we going to do this? So we will, today class is one algorithm that help us to do comparison of strings. Okay, so which is the closest, or not just for spelling checker, maybe you are in another field in computational biology that or in chemistry, in science courses that we use a lot of code, to represent certain in science, in chemistry, in bio, they are using a lot of coding for to represent like aluminium. That's what do you call that one? Chemistry chart, that one. Okay. Anyway, for example, if we have an application or something that are using certain code, okay, abbreviation sometimes also to represent a short form of something. So because this is basically a string, we are still dealing with strings. Okay, so we can use this algorithm also. Align two sequence of nucleotides, assuming this is from computational biology. So this stand for certain code. So how are we going to check the similarities and so on? Okay, string distance is a measure of how alike two strings are to each other. Okay, so that is the idea of checking similarities of strings. All right, so for example, like this code, okay, then we can, this is the input and this the output, for example. So we need to do, what need to be done is to align them together, put them together, the input and the expected output. Okay, for example, like A, G, C. So how many characters is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. How about this one? Okay, this is the final output. Anyway, okay, so resulting, okay, this is the input and the expected output. We can do some kind of edit process actually. Okay, so what is edit process? Basically over here, A, we try to match the one that is similar. So AG, you can take all the earlier input and then you try to make the same with this one. MARK is you can bring them to the targeted, but which is not similar. Okay, something is missing here. Okay, so if I put it, align them together, AG is similar. The one in red is the similar one, but then I need to add something. Okay, and this is empty, but I can add T and G, TAG, but second G, you can always delete. Okay, under edit, okay, you learn from the list that you have learned is maybe database. In doing database, you can do some uh, process what is known as edit. Okay, what can we do when we edit? We can replace, we can add, we can delete. Okay, so those are the tasks that can be done when we do some edit. Okay, a process of doing editing. So when we align this one, so that what can be done. Okay, so we can add, we can delete, and we can also substitute. Okay, adding and then also okay, so we will look into this application and also the algorithm. All right, so searching keywords via the net. Usually, we wanted to type maybe Malaysia. However, we mistype it as Malaysia. Okay, MALY. Okay, and then you know that Google will ask you. Okay, are you? They give us the nearest one. Yes, then, but of course for Google, usually they ask you to confirm, is this what you mean? If not, even if they are not, so they will predict the nearest to the input for your character, and based on the similarity and using this technique, they will suggest uh, this Malaysia must be Malaysia. Okay, so they will give us all the site. Okay, so that is the real application. So how can we do this? So we can base on very interesting operation, or what is known as edit distance. Okay, based on the process of editing and looking at the location or the spaces between the characters or between the string. So it's also known as Levenstein distance or evolutionary distance. This is actually in 1966. Okay, the when you can read the paper from him to understand better on this algorithm. Okay, it is the most common measure to expose the dissimilarity between two string. Okay, even 1960, but the what we wanted to learn in our class is about the concept. Okay, the concept of building this algorithm, and of course now you can always improve this or enhance it. Anyway, okay, so what is Levenstein distance? Given two string, okay, two string, of course, the first string, the input, and also our expected, usually the second one, the minimum number of operations, or what we call as edit, to change from one string to another. Okay, so in terms of edit, as I mentioned just now, usually we will able to do at the character level, we can do deletion. Okay, we use D, insertion as I to insert, and also to substitute. Okay, sometimes they say insert is addition, like you adding thing. Delete, insert, substitute. Okay, that is the basic three operators that can be done in this algorithm. All right. Okay. For example, to find the distance between these two words, okay, intention and execution. Okay, so our source string is intention. Okay, and what we expect is to be execution. So from this you can see that maybe the last four TION is similar. Okay, do some alignment, and then you can see that the first four is exactly the same. Uh, and the rest you can say, okay, we will check this character by character. Okay, we align it according to the character. Okay, so if intention, when we match with this, because we try to match the last four to be matched together. So the first one that can be done here is, okay, execution. What can we do? What can we do? Okay, so you need to I will need to be replaced with something here, or we can always actually delete this one. Okay, because we for our targeted is actually start with E, so we do not need I. So you can always do some deletion here. N and E, N will how can we change it to E? So basically we will do substitution. Okay, T to X is also substitution. Substitution, yeah, the term is substitution. E match. Okay, and how about this one? Then we realize that uh, so we need to insert new things here. Okay, so I, so you will, if you add C, then we will get the correct strings. And then for N and U, we can do substitution also. Okay, then we will calculate the score, how many space or the repetition um, of the distance. Okay, how much that we will need to calculate. All right. So the transformation list. Okay, if we refer back to this one. Okay, the process. Okay, the process of doing the editing. The transformation list from intention to execution. So first we take the intention. Then when we delete the first part. Okay. Look at this diagram. So we will delete. Okay. So the process is. So you delete, so you get N tension, and then we will substitute N by E, and then we will substitute T by X, insert U, and then substitute N by C. Okay, maybe looking at the diagram is much easier, but this is the process that involved. Okay, then we can get the what is the type from intention. This is quite far. Okay, if you see that from intention to execution. Okay, 1 2 3 4 5. Okay, so which is quite I mean it's intention. Maybe we are expecting another word, but now because we wanted to change it to execution, so we can assign a particular cost or weight to each of the operation. If we you can just give any heuristic score. If we give it as for a cost of 1, so the process is for each step is actually 1. So we have 5 step, so it become 5. Okay, uh, this one if each operation has cost of 1. However, if we, in order for us to substitute, if we put substitute cost as 2, so the distance will be 8, because each substitute, over here, if we do substitute, okay, because we need to match and then we need to substitute. So if it's this one 2 4 6, okay, the 2 4 6 and then plus 1 1, so it become 8. The distance between them is 8. Okay, so the process of doing this, because there'll be a lot of option, isn't it? So we will calculate it based on the minimum edit distance. This is where you can always recall, for example, your searching strategy in your first year. Yeah. Okay. Anyway, this is again, as I mentioned, we go back to a searching technique actually. So that's why when you study AI technique, we will always keep or we need to learn the primitive technique in terms of doing searching. Okay, so searching for a path from um, from the start string to the final string. So if we wanted to put it um, as an algorithm, so or as a searching strategist, remember that from your first year, remember that you do A star, uh, shortest path and so on. So we must have our initial state and then we must know our goal state. Okay, from the initial to the goal state. And for example, for our case, from intention to execution, we actually will have our path or the sub goal. Okay, the sub goal. Okay, and you will. I always mention previously. We do the four tuple. You will need the initial state, your goal state, the operators, and the the nodes and also the arc. You know, from each of the string that you wanted to process, you can draw them as actually as a node. uh, this is a node, this is a node, and in between them you will have arc, which is the path. Okay. Okay, so from intention, for us to arrive to to arrive to execution, we will also have what is the sub goal. Okay, the goal state is the word we are trying to get to. Okay, we will process it accordingly. And the operators in our case will be the edit processes, which is delete, insert, or adding, and then substitution. Okay. This one also dependent on the references. Sometimes they will use a different code. Okay, DIS and or maybe they use add for inserting. Okay, and then the path cost will be what we want to minimize the number of edits. So when we do the searching, we will try to get the minimum score. Okay, if we, for example, if we do doing the deletion, okay, I'm looking at the diagram actually. Intention, so it will delete I, or if you wanted to do if you wanted to insert intention, so for example, I'm execution, so I can add E, okay, or if I wanted to substitute I with E. Okay. However, we will take the uh, minimum one in terms of scoring. Okay. So how do you calculate the minimum? Okay. The space of all edit sequence. When do this, when it will come back as a search tree. Okay. So the spaces of looking for answer towards the goal state will be huge. Okay, so the space of all edit sequence is huge. So loss of possible sequence wind up at the same state, where you remember from searching it can become a loop, and it's very difficult for us to keep track all of them. Okay, so just the shortest path to each of those revisited states. So we will use the shortest path technique. Okay, so for two strings, so we change this into our coding. Okay, for two string, x of length is n and y of length is m. N is the our source and m is our targeted. So we can define the distance as ij. Okay. The edit distance between, so you can just do it as an array. Okay, the first I character of x, and we will look into each distance. Okay, maybe this another diagram that will be easier. Okay, the base case for edit distance function. Okay, if of course the first part, we are like your searching technique, we haven't moved to any place, so uh, no operation involved. It's from your starting from your initial. Okay, so then we move on. Okay, the first character from our targeted um, to our goal. Remember that, if you can remember also our water jug uh, problem, in your first year water jug, that will be quite an interesting technique, or something that you can apply if you wanted to remember how we do this one also. Okay, so basically you will need to look into, we will check it one by one later on. Okay, from the string, so you will just look into the first character towards the goal, and also our goal later on is for the our targeted one. Okay, zero character and also J, so the operation will follows. Okay, so in doing this one is basically we are doing what is known as dynamic programming. Okay, it's a tabular computation. uh, we can use a table driven method to solve problem by combining solution to the sub problem, because in order for us to reach the final goal, we will need to do our sub goal. Okay, so we can check I mean when we do the reasoning, we can do it, remember in searching we can always do top down and bottom up, so we can do bottom up. We compute the smallest ij, and then we will continue. Okay, for each of the steps. All right. Okay, so we can do our normal process of from initial, from a starting point. Okay, do the initialization. Okay, this is what we going to process from this one, which is I and also J. Okay, from I 1 to this one. Okay, so we will process this, and we will base on and the operation that can be done. Okay, is deletion. Okay, we will plus 1, and then insertion and substitution. And if we read the goal, so we will use the termination. That means that we have reached the final uh, output, or our targeted output. Okay, how are we going to do this? Okay, to help us in doing this dynamic programming, basically it's actually a repetition of the process. Okay, so you can just use the come up with a matrix table. Okay, and we will put the string vertical and horizontal to match. Sometimes they use top. They put it's okay. You can put it at the top. I mean, not necessarily to be like this. You can different references will draw it differently, as long as you have the matrix in this diagonal style. Okay. This is where we start from our initial state, which is actually 0. So it won't, we start from here. Okay, initial state. And then we will apply the operators in order for us to reach or to check, okay, the similarities of each of the characters. Okay, this is the distance, okay, of each of the distance, and also the length of our string that we make as an input. Actually, I will not discuss further on this because this we will do. I wanted you to do this for your tutorial for tomorrow. Okay. This is actually here. Complete the table and determine the minimum edit distance between the two words. Okay. I will let you continue with how they actually change this one using the operators by watching the two videos that's in the spectrum. Okay. Then you can attempt the continue with I mean the video will actually describe step by step on these operators, and then in the tutorial question you apply the same method for you to solve another string, just to exercise with another string. Okay. I will let you go and watch the two video because these references is actually from Juravsky, and the two videos is from Juravsky himself. Okay, you can follow his discussion in how we do. This is, as I mentioned, this is basically we are doing searching and applying these operators. Okay, you can recall your um, how we do from initial to the goal, and we replace it according to the sub goal. Okay. Then we will discuss this one again tomorrow for another exercise. Is it okay, everyone?
Okay, Doctor.
Yeah. How about the test? Everyone, are you happy with the test? Quiz. Okay, it's 15%. Okay. Anyway, I hope it's not that difficult, and hopefully each one will get more than 12 marks, inshallah. All right. I let you go. Okay, please watch the video and answer. You can attempt the tutorial first. If everyone is fine, tomorrow we will do another exercise and discuss about your project also. All right. Thank you, everyone.
Thank you, Doctor.
Thank you, Doctor.
Okay. Anyway, this edit distance not necessary just for us to apply for this. You may also use this Levenstein algorithm in another task also maybe. Okay. All right. Thank you. See you tomorrow.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Bye bye.